Before we begin, a mandatory disclaimer. While the summary framework for this episode was generated using Notebook LM, every data point and technical specification is based entirely on actual public source material released during the week of June 12, 2026. As AI transitions toward agentic autonomy, enterprise architecture is prioritizing verifiable control over simple model intelligence. The rapid-fire product releases we saw this week across AWS, Azure, Google, and Anthropic function as interlocking components of the foundational architecture required for 2026. This diagram shows a three-dimensional grid with 5 distinct layers. We are going to use this framework to map the week's 13 separate updates into a single 2026 enterprise stack. We will analyze this intelligence by building from the ground up, starting with silicon processors, moving through data pipelines and models, and finally reaching the top level of cybersecurity policy. Broad AI capability creates significant risk unless it sits on top of mathematically proven hardware and operates under risk-weighted security protocols. We start at Layer 1, hardware and telemetry. AWS has moved its custom-designed Graviton 5 processor into general availability on the EC2 M9G and M9GD instances. Graviton 5 is the first CPU in the AWS fleet to support PCIe Gen 6 and DDR5 8800 memory, delivering a 33% reduction in intercore latency compared to the previous generation. The base layer of our stack now shows a server node protected by a locked geometric boundary. This is the new Nitro isolation engine, which uses formal verification to mathematically prove virtual machine isolation at the silicon level. Connecting upward from that hardware, a stream of multicolored pipelines routes telemetry into a storage block. Efficient hardware requires aggressive observability, which brings us to Microsoft announcing the general availability of Azure Monitor Metrics Export. Microsoft is migrating away from legacy diagnostic settings in favor of data collection rules, or DCRs. This approach natively preserves multidimensional platform metrics, ensuring that downstream correlations retain their granular details. By utilizing DCRs, engineering teams can filter specific metric names and reduce end-to-end data export latency down to exactly 3 minutes. To manage the resulting data volume, Google Cloud has pushed its Storage Insights datasets into general availability to help teams handle large-scale unstructured data footprints. Storage Insights automates a query-ready index of your entire storage estate directly into BigQuery. It moves architects away from manual, static inventory collection and enables live behavioral analysis. The datasets capture object-level actions and operational errors down to the exact object prefix, giving engineering teams the data needed to resolve expensive automated 429 rate-limiting loops. Raw compute power is unusable for autonomous AI without this type of minute-by-minute, multi-dimensional telemetry governing it. Moving up to Layer 2, we look at how data is safely piped into AI models. This week, Apache Spark 4.0 reached general availability across all Amazon EMR deployment options. The integration of Spark Connect utilizes a gRPC-powered client-server architecture. AI engineers can now build and execute PySpark data transformations remotely on serverless compute directly from their local IDEs. Spark 4.0 introduces the variant data type, which natively processes unpredictable JSON and IoT inputs without predefining schemas. This eliminates the need to maintain fragile ETL pipelines for feature engineering. In the second layer of our stack, an LLM node interfaces with a structured database via a protocol bridge. This is Microsoft's SQL Model Context Protocol Server, or MCP, now in general availability. The MCP server establishes an open standard architectural framework. Autonomous AI agents can use it to safely inspect database schemas, discover metadata, and fetch structural contexts. Because the protocol handles the structural context automatically, engineering teams no longer have to write custom data access APIs to connect their agents to their data. AI experts can instantly ground production models in real-time enterprise data, using relational query access to reduce hallucination rates. The current bottleneck for enterprise AI remains the ability to safely pipe structured data into a context window. This generated video visualizes a structure autonomously assembling itself from raw code, representing Layer 3, the Vanguard models. Anthropic has officially launched Claude Fable 5, alongside its unrestricted counterpart, Mythos 5. This architecture achieves a significant jump in long-horizon engineering autonomy. In testing, the model successfully executed a codebase-wide migration across a 50 million-line Ruby repository in a single day. The model's capabilities extend into life sciences, where it autonomously generated novel molecular biology hypotheses that were later corroborated by independent lab findings.
To control these advanced agentic capabilities in a production environment, Anthropic also moved their managed agents feature into general availability. In the third layer of the stack, the brain icon is physically separated from a mechanical gear. This illustrates Anthropic's core architectural shift, decoupling the open-loop stochastic policy of the LLM from the closed-loop controller of the infrastructure harness. The managed infrastructure provides standardized primitives for sandboxed code execution, state externalization, and persistent session management. By enforcing an integrated generator-evaluator architecture, the platform creates deterministic verification loops that yield clean, linearly auditable action logs. Enterprise AI has moved past the era of unpredictable prompt wrappers, adopting a model of systematically constrained execution engines. We now hit Layer 4, the cybersecurity reality. The Darktrace Global Annual Threat Report for 2026 details a threat landscape that has adapted to the AI era. The report highlights that identity compromise and the abuse of native SaaS platforms have eclipsed pure vulnerability exploitation as the primary attack perimeter. Adversaries are moving with significant speed. CVE volumes are growing 20% annually, and threat actors routinely exploit weaknesses before public disclosure occurs. This graphic shows genuine headlines overlapping with fabricated social media posts. This illustrates the socio-technical tactics detailed in a recent OpenAI report regarding disrupted PRC-linked influence operations. The threat actors ran a data center bandwagon campaign, utilizing ChatGPT to generate content, blaming AI data centers for driving up electricity prices. They weaponized real domestic debates to mask their origin and aggravate public distrust. Modern adversaries are bypassing technical walls, opting instead to exploit legitimate platforms and manipulate existing domestic narratives. The federal response to this speed and complexity came this week from CISA via Binding Operational Directive 2604. This directive officially revokes previous uniform patching mandates. It establishes a risk-based approach, shifting focus away from treating all vulnerabilities equally. This diagram maps a risk-weighting matrix that funnels vulnerabilities down to a single point based on 4 variables: public asset exposure, KEV catalog inclusion, exploit automation, and technical impact. Under this new framework, high-risk scenarios, such as an automated exploit targeting a publicly exposed system, now demand remediation timelines as short as 3 days. To meet those timelines, we see a Google SecOps agent node box in the target and rapidly shrink the resolution countdown. Google Cloud highlighted these specialized AI security agents to help contain rapid exploits. The general availability of their triage and investigation agent leverages Gemini to autonomously analyze telemetry alerts, cutting manual investigation times from 30 minutes down to 60 seconds. The industry is moving toward prioritizing AI-driven containment based on actual operational threat. We cap the stack with Layer 5, governance. Ivanti's 2026 Global Research Report on IT Operations highlights the realities of managing these systems at scale. IT operations are seeing a widening hallucination gap, with 68% of professionals observing AI hallucinations causing operational impact. The prerequisite for scaling AI is establishing a unified IT and security system of record. Mature organizations utilizing this centralized data authority are currently saving an average of 6 hours per week per IT professional. We see similar governance constraints in the Cloud Security Alliance report on the State of Cloud and AI for Financial Services 2026. Financial institutions expect autonomous AI-driven payments to grow rapidly. However, the primary blockers to that growth remain sensitive data leakage and the lack of non-human identity governance. Deploying an AI agent is a technical task. Establishing the central data authority required to prevent it from leaking data or disrupting operations is the final hurdle. Viewing the culmination of the week's updates, our 5-layer stack is now fully constructed.
The industry has collectively realized that high-scale AI capability without strict infrastructure harnesses and risk-weighted security is a significant liability. Whether it's AWS Graviton 5 at the silicon layer, Microsoft's SQL MCP bridging the data, or Anthropic's managed agents executing the code, every update this week is solving for verifiable control. To stay ahead of these architectural shifts and understand the data behind the headlines, check out the source of this intelligence. Subscribe to the YouTube channel at @ILEstrin. That's youtube.com/@ILEstrin for more deep dives into cloud, security, and AI insights. That wraps up this week's Intelligence Brief. Stay secure and see you in the next breakdown.